The evening of November 14, 1940, marked a turning point in aerial warfare. A massive armada of 500 Luftwaffe bombers streaked across the darkened skies toward a British metropolitan target, guided not by visual landmarks or navigator intuition, but by an invisible technological marvel: concentrated radio wave transmissions. This represented the Führer's classified technological advantage, one that appeared unstoppable to military strategists. Yet a young scientist barely approaching his 30th birthday declared boldly, "These signals are within my detection capability." His colleagues dismissed him as delusional. Senior military commanders ridiculed his unconventional detection apparatus. However, his groundbreaking findings accomplished far more than preserving countless civilian lives. They revealed the Reich's most closely guarded operational secret, one possessing the potential to fundamentally alter the conflict's trajectory. During a frigid evening in late 1939, Dr. Reginald Victor Jones occupied his modest workspace at London's Air Ministry headquarters, scrutinizing a deciphered German transmission that defied logical interpretation. This physicist, recently turned 28, had joined British intelligence operations mere weeks prior, assigned to investigate Nazi scientific advancements. This particular intercept, however, possessed a distinctly different character, one that inspired genuine dread. The decoded message referenced something designated as XJET, alternatively termed the X device. It contained mentions of directional transmissions, geographic positioning data, and precision targeting capabilities that appeared to describe armaments unprecedented in modern warfare. Jones re-examined the transmission repeatedly, his fingers trembling involuntarily. Should his analysis prove accurate, Nazi Germany had engineered a methodology for striking British urban centers with extraordinary precision, even under absolute darkness conditions. His assertions met widespread skepticism. Air Marshal Sir Trafford Leigh-Mallory scoffed at the notion of radio-guided bombardment, declaring it physically impossible due to Earth's curvature alone, dismissing Jones's concerns as speculative fiction unworthy of serious military consideration. Nevertheless, Jones couldn't abandon his investigation. Throughout 3 consecutive weeks, he had systematically assembled fragmentary evidence, wreckage from a crashed Luftwaffe bomber, containing peculiar radio apparatus, intercepted German Air Force communications mentioning directional beams, and a system called Nickebein, plus reports from RAF aviators who had detected unusual radio transmissions while conducting operations over German territory. Late into that particular evening, Jones ranged his collected materials across his workspace: photographic documentation, technical schematics, signal analysis reports, and deciphered communications. Somewhere within this complex puzzle lay the genuine truth. Should his hypothesis prove correct, Britain faced dangers far exceeding current assessments. For months, German air forces had conducted bombing campaigns against British population centers, yet their strike precision remained constrained by meteorological conditions, insufficient visibility, and defensive countermeasures. British strategic planners operated under the assumption that nocturnal precision bombardment remained technologically unfeasible. But what if Nazi engineers had circumvented these limitations? What if they possessed methodology for guiding bomber formations with pinpoint accuracy, independent of visual conditions? Jones retrieved his telephone and contacted his colleague, Charles Frank, requesting his immediate return despite the late hour, explaining that he had potentially uncovered something of critical importance. 60 minutes later, both men sat surrounded by documentation and diagrams. Jones proposed a theoretical framework. Suppose the Germans were employing intersecting radio transmissions. A bomber navigates along one directional signal, and upon detecting a second crossing transmission, the aircrew knows precisely when to release their payload. The principle resembles following railway lines to an exact destination. Charles examined the technical drawings carefully. The concept demonstrated brilliant yet terrifying ingenuity. But was it technologically achievable? Jones responded quietly that he believed it was not only possible, but already operational. Should Jones's analysis prove accurate, Hitler's Air Force stood poised to execute a destruction campaign of unprecedented precision and devastation. The sole obstacle between Britain and catastrophe was one young physicist advancing an unconventional theory about radio guidance systems, a hypothesis that virtually nobody accepted as credible. The following morning, Jones demanded an emergency consultation with Britain's highest military and scientific leadership. He received 15 minutes a quarter hour to persuade skeptical generals and air commanders. That an invisible menace represented genuine danger. The conference room's atmosphere proved intimidating. Assembled around the table sat some of Britain's most influential military strategists: Air Chief Marshal Sir Hugh Dowding, Scientific Counsel Henry Tizard, and numerous senior intelligence personnel. They regarded the young physicist with barely concealed impatience. Jones commenced nervously, but gained confidence as he presented his accumulated evidence. He displayed the intercepted transmissions, the anomalous equipment recovered from crashed German aircraft, and most critically, his mathematical calculations demonstrating radio beam functionality. Using hastily sketched illustrations, Jones explained his theory. Envisioned two radio broadcasting stations positioned in Germany, each projecting a concentrated beam. These transmissions intersect above a British city, Coventry. For instance, a German bomber simply maintains course along the primary beam until their instruments register the secondary beam intersection. At that precise instant, they know with certainty they have reached the target coordinates. Visual confirmation becomes unnecessary. Weather patterns become irrelevant. Darkness provides no protection. The beam intersections provide exact positional information. A senior air marshal interrupted, declaring the concept preposterous, insisting radio waves naturally disperse and diffuse rather than maintaining narrow concentration across hundreds of miles. However, Henry Tizard, the scientific advisor, leaned forward with genuine interest, acknowledging that with appropriate frequency selection and antenna engineering, the theory possessed technical validity. He questioned what concrete evidence Jones possessed, indicating the Germans had actually constructed such a system. Jones presented his most compelling proof: a captured German pilot who, during interrogation, had inadvertently mentioned training exercises involving a beam navigation system, before recognizing his error and refusing further discussion. Though the pilot subsequently remained silent, this slip proved sufficient. Jones urgently requested resources, aircraft equipped with sensitive radio detection equipment, to search for these transmissions, technical specialists to analyze discovered signals, and authorization to immediately develop defensive countermeasures. Because, as he emphasized, if his analysis proved correct, these beam systems were already operational and could be deployed that very evening. The conference room fell silent. Finally, Dowding spoke, acknowledging that if Jones was mistaken, valuable resources desperately needed elsewhere would be squandered. However, if the analysis was accurate, he paused as the implications registered. Every British metropolitan area faced imminent risk. Jones received authorization for the requested resources, accompanied by a stern warning against waste. Within hours, Jones assembled a compact team of scientists and radio specialists tasked with locating Hitler's invisible guidance beams and engineering solutions to neutralize them before they could facilitate the destruction of British cities. The team worked continuously. Modified RAF aircraft flew systematic search patterns across England, their radio receivers scanning frequency ranges. For 3 days, they detected nothing. Jones's critics grew increasingly vocal, with one senior officer complaining about squandering resources on phantom pursuits. But on the fourth night, everything transformed. An aircraft operating near Derby detected an anomalous signal, a steady, concentrated radio beam originating from German territory, passing directly above the city. Within hours, they had identified additional beams, each precisely aimed at British industrial centers. Jones's hypothesis had been validated. The beams existed as real phenomena, and now commenced a desperate race to determine how to neutralize them, before the Luftwaffe could employ them to rain devastation upon Britain. With confirmation of the beam system's existence, Jones and his colleagues worked frantically to understand the precise operational mechanics of the German technology. They assigned it a code name derived from intercepted references, Nickebein, the German term meaning crooked leg. The system's design proved elegantly simple yet devastatingly effective. The Germans had constructed several powerful radio transmitters positioned along the European coastline. Each projected a narrow beam using specially designed antenna rays. The ingenious element involved how the beams encoded directional guidance information. Jones explained to his team while indicating oscilloscope readings. The beam wasn't uniform in character. German engineers had divided it into 2 overlapping sections. On the beam's left side, aircraft radio equipment received Morse code dots. On the right side, dashes were transmitted. However, when flying precisely centered within the beam, the dots and dashes overlapped perfectly, generating a continuous audio tone. It functioned like audio guidance rails, So long as the pilot heard that steady tone, he knew with certainty he was maintaining proper course along the beam. Charles Frank studied the data with growing appreciation for the engineering sophistication. The system was brilliantly conceived, simple enough for any pilot to utilize, yet accurate to within several hundred yards across hundreds of miles of distance. No wonder German commanders expressed such confidence regarding nocturnal bombing operations. Yet understanding the system represented only half the challenge. Now they needed to neutralize it. Jones began developing defensive countermeasures, but confronted a critical complication. If the Germans realized the British had discovered Nicobine, they might simply activate backup systems or modify their approach. The countermeasures required sufficient subtlety that Germans wouldn't immediately recognize what was occurring. Direct jamming of the beams would prove too obvious, Jones explained during a late-night consultation with Dowding. Instead, a deception strategy was required. British transmitters would broadcast signals on identical frequencies, slightly offset. To German pilots, equipment would appear to be malfunctioning or the beam would seem unreliable. They would release their bombs prematurely, belatedly, or miss target coordinates entirely, yet wouldn't immediately understand why. This represented a strategy of sophisticated deception rather than brute electronic force. The British commenced establishing their own transmitter network, carefully positioned to interfere with German beams without making the interference pattern obvious. They designated this Operation Meekening, a term describing leading the enemy astray using false signals. The initial test occurred on an overcast June evening in 1940. German bombers approached a munitions manufacturing facility in the Midlands, following their Nicobine beam, but British transmitters were now active, broadcasting confusing signals. The German bomber crews, uncertain of their position, released their ordnance 5 miles from the intended target in an unpopulated field. In his office, Jones monitored incoming reports. The factory sustained no damage, no casualties occurred. The bombers had completely missed their objective. The countermeasure had functioned as designed, yet this represented merely the beginning. The Germans possessed more sophisticated systems under development, and the invisible war of electromagnetic beams and countermeasures was about to escalate dramatically. The precision and careful design of British defense systems created massive confusion among German engineers trying to figure out what was going wrong. The Luftwaffe started to suspect British interference, but couldn't prove it. Their intended design looked solid. Their pilots were well trained, yet somehow the beams weren't working the way they should. This confusion bought Britain valuable time to strengthen its defenses and prepare for what was coming next. Jones had turned science into a weapon more powerful than any bomb. His antenna systems were saving thousands of lives, protecting important factories and buildings, and destroying German confidence in their technology. And the Germans still couldn't figure out what was happening. Just as British defenses were beating Excurt, Jones discovered that the Germans had developed another system. In decoded messages from early 1941, references appeared to Woden, a one-eyed god from mythology. Jones immediately understood what this meant: a single beam system more advanced than anything before. The WWII, as it was officially called, was a game-changer. Instead of using multiple crossing beams, it used just one highly accurate beam combined with a transponder device in the aircraft. The ground beam would send a signal to the aircraft's transponder, calculate its distance based on how long the signal took to bounce back, and give continuous distance information to the bomber. Combined with beam guidance, this allowed incredible accuracy with just one ground station. Jones described the system as both brilliant and terrifying during a private meeting with Churchill. He explained that while they had built jammers for Nicobine and confused the multiple beams of Excurt, WWII was different because it was a two-way communication system. Jamming it would immediately tell the Germans that the British knew about it. They needed a different approach. Churchill, smoking his famous cigar, looked at Jones carefully and asked what he proposed. Jones replied with one word: deception. Instead of jamming their signals, British forces would answer them. They would build their own transponders that could receive German signals, but send back false information, making German crews think their bombers were somewhere they weren't. While technically difficult, this was their best option. Churchill smiled grimly, noting that Jones was proposing to speak to German bomber crews in their own electronic language. While lying to them, he approved the plan and ordered immediate action. The technical challenge was huge. Jones and his team had to figure out how the WWII transponder worked without having an actual device to study. They worked from intercepted signals, mathematical calculations, and small clues in captured equipment that used similar technology. Dr. Robert Cockburn, an electronic warfare specialist, joined the effort. Working with Jones, they designed what they called a masking beacon, a ground-based system that could detect German WWII signals and respond with false distance information. Cockburn explained the beauty of this system. The Germans wouldn't immediately know something was wrong. Their equipment would seem to work perfectly. The numbers would make sense. The bomber would appear to be exactly where the beam said it should be. But in reality, British transmitters would be feeding them coordinates that were miles off target. Testing the system was nerve-wracking. They couldn't afford mistakes. The first real use came on a night when intelligence showed a WWII-equipped bomber was targeting a naval base. British masking beacons turned on, sending false distance data. The German bomber crew, confident in their position, dropped their bombs exactly where the system told them 5 miles out into the ocean. The naval base was untouched. Over the following days, more WWII attacks were similarly misdirected. German bomber command was completely confused. The system seemed to work perfectly, yet bombs kept missing their targets. Pilots were blamed for being incompetent. Equipment was checked and rechecked, but the problem continued. The Germans never fully understood what was happening. They eventually stopped relying on WWII, blaming its failures on weather interference and technical problems. In reality, Jones and his team had successfully turned the most advanced German guidance system into a weakness. By mid-1941, Jones had become Britain's secret weapon against the Luftwaffe, but his work remained top secret. Most British citizens had no idea that an invisible war was being fought above their heads, or that a young physicist was saving countless lives by manipulating radio waves. The secret almost got exposed in June 1941. A British newspaper, trying to explain why German bombing was becoming less accurate, published an article suggesting the RAF had developed advanced jamming techniques. The article was vague, but contained just enough detail to potentially alert German intelligence. Jones was both furious and terrified. If the Germans realized the full extent of British countermeasures, they might develop completely new systems that would take months to understand and counter. He demanded an emergency meeting with the newspaper editor and government security officials. He told the editor coldly that the article might have just undone 18 months of work, explaining that every word gave German intelligence clues about what to look for. If they pieced it together, thousands could die. The government issued orders stopping any further reporting on the subject. German intelligence did notice the article, but without detailed technical information, they couldn't confirm whether it was accurate or just British propaganda. The secret held, though barely. Meanwhile, Jones's team kept growing. What had started as a handful of scientists had grown into a large organization, with hundreds of people operating a network of monitoring stations, jamming transmitters, and analysis centers. They watched every radio frequency the Germans might use, analyzed every new signal, and developed countermeasures before systems could even be used in combat. In one remarkable case, Jones's team detected a new German beam system during testing, before it was ever used in battle. By the time the Luftwaffe tried to use it operationally, British countermeasures were already in place. The system failed so badly on its first use that German commanders thought it was broken and abandoned it completely. The invisible war had reached a stalemate. German engineers kept developing new systems, but Jones and his team kept stopping them. The Luftwaffe's ability to accurately bomb British targets had been effectively destroyed. Churchill, during a private moment with Jones, acknowledged how important his work was, saying that Jones had given them time to rebuild forces, time to prepare attacks, time to survive. While the Battle of Britain was won in the skies, the Battle of the Beams was just as crucial, and Jones had won it with math and physics. Jones, always modest, simply said they had done what needed to be done, science serving survival. But privately, Jones understood how significant their accomplishment was. A small team of scientists working with limited resources had stopped what should have been an unstoppable weapon. They had shown that intelligence and innovation could beat brute force. They had saved thousands of lives through clever manipulation of invisible radio waves. While Jones was fighting German beam systems, he stumbled upon something else, something that would prove even more important to the war. While analyzing German radio communications and technical documents, he began noticing references to research at a place called Peenemünde on the Baltic coast. The references were mysterious: advanced weapons, rockets, long-range attacks. At first, Jones thought it might be related to beam guidance systems, But as more intelligence came in, he realized this was something completely different, something potentially more dangerous than anything he'd encountered before. In June 1943, a resistance fighter in Luxembourg photographed a strange document that had been carelessly left in a hotel room by a German officer. The document made its way to Jones's desk. It contained technical drawings and calculations for a rocket, not a small battlefield rocket, but a massive missile capable of carrying a ton of explosives across hundreds of miles. Jones felt his blood run cold. If the Germans had developed such a weapon, it would change warfare forever. Unlike aircraft, rockets couldn't be shot down by fighter planes or anti-aircraft guns. Unlike bombers, they didn't need pilots who took a long time and lots of resources to train. If launched in large numbers, rocket weapons could destroy British cities with no way to stop them. He immediately briefed Churchill and military leaders. Many were skeptical. One general scoffed, calling rockets something from science fiction, not serious military intelligence. But Jones had learned from the Bean battle that when something seemed impossible, that didn't mean it wasn't real. German engineers had already proven they could create remarkable innovations. Why wouldn't they develop rocket technology? Jones pushed for spy plane missions over Peenemünde. In June 1943, RAF photo planes captured images of the facility. Analysis showed what appeared to be large rocket-like objects on test stands. There were also unusual circular structures that Jones identified as launch pads. He told the skeptics that this was real. The Germans had working rocket weapons and were preparing to use them against Britain. They needed to act immediately. On the night of August 17th to 18th, 1943, the RAF launched Operation Hydra, a massive bombing raid on Peenemünde. Over 600 bombers dropped nearly 2,000 tons of explosives on the facility, destroying workshops, killing scientists and engineers, and setting back the German rocket program by months. It was an expensive raid. 40 British bombers were lost, but it disrupted German rocket development. At a critical time, the Vega rockets that eventually hit London came later, and in smaller numbers than originally planned. Jones's intelligence work had once again saved countless lives. But the bigger secret Jones had unknowingly helped expose was this: the same scientists working on rockets at Peenemünde were also doing nuclear research. Documents found after the war showed that Germany's atomic program was centered at several sites, with coordination happening through facilities like Peenemünde. By helping disrupt operations there, Jones had accidentally interfered with German nuclear weapons development. If the Peenemünde program had continued without interruption, Hitler might have gotten atomic weapons. The consequences would have been beyond catastrophic. Jones didn't learn the full scope of what he'd helped prevent until after the war ended. When he did, it gave him nightmares. His work on unusual antennas had led him to discover beam guidance systems, which led to rocket intelligence, which disrupted nuclear weapons development. One young physicist's curiosity and determination had potentially saved civilization itself from unimaginable destruction. When the war ended in May 1945, Reginald Jones was just 33 years old. He had spent 6 years fighting an invisible war that few people knew existed. His work had saved thousands of lives, stopped countless tons of explosives from hitting their targets, and helped expose Hitler's most dangerous secret weapons programs. In the years right after the war, Jones's story stayed classified. The techniques his team had developed were too valuable to reveal publicly. The Cold War was starting, and the same electronic warfare methods that had beaten the Luftwaffe might be needed against the Soviet Union. But slowly the story came out. Jones received many honors, including a knighthood. He went back to university life, becoming a professor at Aberdeen University, where he taught a new generation of scientists. Many of his students went on to careers in defense research. Carrying forward his legacy, Jones never wanted fame. When interviewed later in life, he always gave credit to his team, saying he was just one person and that the Battle of the Beams was won by hundreds of scientists, engineers, and operators working together, insisting they deserved recognition, not him. But those who worked with him knew better. Jones had been the driving force, the one who refused to accept impossible as an answer, who fought for resources when others doubted, who made connections between different pieces of intelligence that others couldn't see. The technical innovations Jones created became the foundation for modern electronic warfare. The principles his team developed, detecting enemy signals, analyzing them, developing precise countermeasures, using deception instead of just jamming, are still taught in military schools today. Perhaps more importantly, Jones' proof that scientific intelligence could win wars. Before Jones, intelligence was mainly about spies and breaking codes. Jones showed that technical analysis, physics, and engineering were just as important. After the war, every major military created scientific intelligence services based on Jones's wartime organization. The unusual antenna that exposed Hitler's biggest secrets wasn't really unusual at all. It was the work of a brilliant mind that refused to be limited by conventional thinking. Jones understood that modern war would increasingly be fought with technology, and that winning required not just better weapons, but better understanding of what the enemy could do. In his autobiography written decades after the war, Jones thought back on those desperate years, explaining that they were fighting for survival and used every tool they had: math, physics, engineering, and creativity. The Germans were tough opponents with excellent scientists and engineers. They won not because they were smarter, but because they were more flexible, more willing to try new approaches, and perhaps a bit luckier at key moments. But those who knew the story understood it wasn't just luck. It was one man's refusal to dismiss the impossible, one man's insistence on following the evidence wherever it led, one man's creative genius in solving problems that others didn't even understand. Reginald Victor Jones died in 1997 at age 86, having lived to see his work declassified and recognized. His obituaries called him one of the war's unsung heroes. Perhaps the greatest tribute came from a former German Luftwaffe pilot who, after the war, learned what Jones had done. The pilot said that they thought their beam systems couldn't be beaten, never knowing there was one British scientist who understood them better than they did, who could reach into the invisible and turn their greatest advantage into a weakness. If Germany had someone like Dr. Jones, perhaps the war would have ended differently. They were fortunate they didn't. That may be the most important legacy of all. Jones and his team didn't just defend Britain. They showed that science, creativity, and determination could overcome any threat. They proved that one person with knowledge and courage could change the course of history. The invisible war Jones fought saved a nation. The techniques he created continue protecting free societies today. And the lesson he taught, that impossible simply means not yet understood, continues inspiring scientists and engineers around the world.